So let's go ahead and get going to section 3. Believe it or not, you're only going to have 4 sections, and then you're going to have the first half of your chapter 3 test. Okay, so I've got to look back, but we actually might have that before the end of this quarter. Okay, because we only have 2 more things to cover, and one of the things we'll cover is today. And so first of all, we're going to talk about optimization with linear programming. And so first of all, if you notice, it says companies hope to maximize their profits and or minimize their costs. At least successful companies do that. Okay, you know, they want to make the most money, but yet they don't want to spend, you know, they want to spend the least. And so that way that's going to give them their biggest profit margins. And so in order to do that, they use linear programming, which is a method for finding maximum or minimum values of a function over a given system of inequalities. And so what we're going to do is we're going to look at how you do linear programming. Now granted, we're going to do it on a scaled down version. Okay, we're not going to do it like what companies do because obviously, you know, yeah. So anyway, so one of the things we need to talk about is what is a feasible region. A feasible region are the vertices of the solution set. And so now what we're going to be doing is we're going to be graphing inequalities, and we're going to be finding the vertices, which are the vertices of the solution set. So first of all, let's go ahead and look at 2 feasible regions, and you should have these all on your sheet. The first one is a bounded feasible region. It basically says the maximum or minimum value of the related function always occurs at a vertex of the feasible region. Okay. Now the next one is an unbounded feasible region. Why is that unbounded, or what's the difference between the 2? Yeah, it's got an open side, a side that keeps going forever and ever. Okay, this feasible region is open and it can go on forever. It is unbounded. Unbounded regions have either a maximum or a minimum. They don't have both. So let's go ahead and look at an example. So we're going to go ahead and start with that number 1. So we need to go ahead and go through and graph these. So let's go ahead and look at the first one. We're going to start with 3 is less than or equal to y is less than or equal to 6. And then
You just grab one.
How many colors do we need?
This one you're going to need quite a few. Okay. So let's look at the first one. The first one tells you about 3, correct? And so for 3, I'm going to do a horizontal line at 3 because that's what y equals is. Okay, so I'm going to do a horizontal line at 3. I'm going to change that to yellow. Maybe not yellow, that's awful bright. Let's try this yellow. Okay, so a horizontal line at 3. I'm also going to do a horizontal line at 6.
In a different color?
No, same color. So for that first equation, you're going to have 2 horizontal lines. You're going to have one at 3, one at 6, and you're going to shade in between. Okay. So that's your very first This next one says you've got a slope of what? 3, a y-intercept of what? 12. So I need to go ahead and place a dot at my y-intercept of 12. Okay.
Different colors?
Yep, different color.
What is the 12?
So the 12 is your y-intercept. So 6, 7, 8, 9, 10, 11. So it's actually 1 down from the top. And it's got a slope of 3. So how do I do a slope of 3?
Down 3 to the left.
Yeah, I'm going to have to go down 3 to the left 1. Because I don't have any room to go straight up.
What's your top set?
That's your y-intercept.
So that's 12.
Yes. Okay, so I'm going to go ahead and use a solid line again. Okay, and now I need to figure out which direction do I shade. So let's pick a point. Let's pick 0, 0.
Dotted and solid lines count
To the right.
in that way.
Generally, all of these will be solid. You won't have any dotted on this stuff. So if I plug in 0, 0, I get 0 is less than what? 12. Is that true? Yeah. Now, one of the things about shading is, you know it can only be a solution if it's shaded twice, right? So really, you don't have to shade necessarily the whole bottom of the graph. You just need to shade the area that's for sure shaded with the yellow, because that's the area that's already shaded. And so in order for it to be a solution, it has to only be shaded twice. And so now we've got one more after that. What can you tell me about the next line?
6.
Y-intercept of 6. So there's your y-intercept of 6. Slope of,
Down to 1.
so down 2 over 1. Okay. So let's figure out which way we shade. So let's pick 0, 0 again. To the what?
Left.
Good. So do you kind of see now which way is all shaded, all three? And once again, I really don't need to shade much more than what I've shaded, because in order for it to be a solution, it has to be shaded all 3 ways. So what shape is shaded all 3 ways? Trapezoid. Nice job. Way to remember that from geometry. Okay.
Come on.
Okay, so biggest thing what we need to do is we need to go ahead and mark our 4 vertices, which basically the 4 vertices are the endpoints of the shape. And then what I'm just going to go ahead and do is darken in my shape right here. Now it looks like all of yours should be on a point except for one. The one on the right, yep, that's. Which one should be on a point? This one. Now what we're going to want to do is we're actually going to want to write down the coordinates of each of those points. So we need to write down the coordinates. So let's start with the bottom left. What are the coordinates of this number, a point on the bottom left? -3, 3. So that's my first one. -3, 3. Let's go to the top left.
-2,
6.
-2, 6. Okay. What's the next one going to be? Let's go to the 0, 6. Okay, and then this one, actually I'm going to tell you, crosses halfway in between those 2 points. So what will the x coordinate be? 1.5, yep, and then up how high? 3. Okay. So I'm going to go ahead and let you deal with decimals there. So 1.5 and 3. So when you've written those 4 down, now what we're actually going to do is we're going to utilize this equation right here. And I'm going to plug each of those points into that equation. And then I'm going to evaluate those numbers. So let's first of all start with the first one, -3, 3. So I'm going to take 4 times -3 minus 2 times 3. What does that come out to be?
We do that for every single
Yes.
vertice?
Yes.
Not
Not really. -, what? 18. Very good. So now what I'm going to do is the next one. I'm going to take 4 times -2 minus 2 times 6. Negative what? Okay, -20. So now I'm going to take 4 times 0 minus 2 times 6. What? -12. And now I'm going to take 4 times 1.5 minus 2 times, whoa. Yeah, minus 2 times 3. There we go. And what do you get there? 0. So now we need to evaluate these 4 points. This is a bounded region, so it has both a max and a min. The highest of those numbers is the max, which is the biggest of all those numbers. 0. So this is my max. Okay. What is the minimum going to be? Negative 20, which is at negative 2, 6. Now when we answer the minimum and the max, we actually answer the point that they occur at. We don't answer that specific number. So you can do it as I've done it, where you just label min and circle that point, and max and circle that. Okay. Let's look at another one. Alrighty, so same thing, we've got to go through this entire process. So I have x and negative 2 and 6. So x, what type of lines are they? X is vertical, okay? So I'm going to put a vertical line at negative 2, another vertical line at 6. And what are you going to do in between? Shade them. See, those are the nice ones, the ones that don't. All you have to do is like put 2 lines and go. So go ahead and draw that in. If some of you want to go ahead and move on to the second equation and try and do that, that's fine. We'll wait a little bit to make sure everybody's... Okay, so the next one, what type of lines am I going to use? Horizontal at 1 and 5. What are you going to do then in between those? Shade. Now once again, I don't really need to worry about anything that's not been shaded yellow, because in order for me to have a solution, it's got to be shaded. You know what? I'm going to undo because I actually got right on that line. There we go. There we go. Okay, let's look at the last line. What can you tell me about that line? It has a y-intercept of what? 3. So 1, 2, 3. And a slope of 1. So that means up 1 over 1. There we go. There we go, that's a little bit better. Okay? So now we need to figure out which way to shade. So if I plug in the point 0, 0, which is actually located right here, is that true or false? True, so I'm going to shade. So what type of region do I actually have?
Quadrilateral.
Let's see. I have one here. Have one here. Have one here. And I have one here. So what shape is it? Trapezoid. Yeah, because it is a quadrilateral, but more specifically, it's a trapezoid because it does have one pair of parallel sides. So the next step is to go ahead and find those specific points.
The ones that you.
Yep, the ones.
Hard to see.
So what's the first one?
1, negative 2, 1.
Negative 2, 1. Okay, let's go for the top left. What are we at the top left?
2, 6, 5.
2, what?
5.
2, 5. Yep. What would be another one? So we've done this one, this
5
one.
and 6.
6, 1, and 6, 5, you said? Okay. So now we need to plug those into the given equation. And so I've got negative 5 times negative 2 plus 2 times 1.
2 is
12. So negative 5 times positive 2 plus 2 times 5.
12. Negative 4. Right. Negative 0.
Okay. Negative 5 times 6 plus 2 times 1. Negative 28. Okay. And then negative 5 times 6 plus 2 times 5. Negative 20. So now we're going to evaluate those. The biggest of those numbers is the max. And which one will be the max? 12. Yep.
12. That's what I mean.
12. So there's my max. Where's my min going to be? Negative 28. Yep. There you go. Pretty straightforward. So we're kind of tying together everything we've done this chapter because we started by graphing inequalities, then we added more than 1. Now we're adding 3. So let's go and look at the next one. Yeah, wow. That one looks like lots of fun. So first thing I'm going to do is I'm going to rewrite this so that it's in standard form. 3x plus 2y equals negative 12. Okay. What's your slope?
Negative 3
Yep.
over 2.
Negative 3 over 2. And your y-intercept is what?
Negative 6.
Negative 6. Nice job. So I'm going to go ahead and put a dot at negative 6. So right close to the bottom. A slope of negative 3 halves. Okay. I don't have any room to go 3 halves, so I'm going to actually go up and to the left. Up 3 to the left 2. Okay, which way am I going to shade?
To the left.
To the right.
I
the right.
mean, to the right.
To the right.
Oh, negative 12. Right. Sorry.
Trying to say you have to read?
Yeah. It's just
I don't like glasses.
mine's on.
Next line. Next line. What's our y-intercept?
12.
12. Okay, so one right from the top. Slope of what, folks?
3, 1. Down
3. So I'm going to go down 3 to the left 1. It's not negative, it's positive. But the reason why we went down and to the left is because the two negatives there make it a positive. So,
Oh.
oh,
Do you think any creepers ever get on your website
So-
and listen to your stuff?
so now if I plug in the point 0, 0, do I get 0?
Yep.
0 to work?
That's right.
Yes.
So I'm going to shade.
Yes.
Yes, I'm going to shade this way. Oops. So once again, we're only worried about where it's shaded yellow pretty much.
You still like the whole thing.
Yeah, it's like the whole part of the graph, so.
Am I supposed to shade it all negative 3?
So the next one, y-intercept of what?
-6.
-6, okay. And a slope of +3. So I'm going to go up 3 over 1.
Up 3 over 1.
Yep. Oops, I'm a little bit off. Let's try that one again. Okay, yeah, so you're seeing it's an unbounded one. So let's figure out which way do I shade?
To the left.
To the left. So once again, we're only looking for where it's shaded both ways.
So that whole
Alright.
thing is.
So if you notice, it's going to be here. That'll be one. Then it's going to be up here, will be another. So basically you're following down the yellow line. Right here. Okay, then you're going to go up the
What are you talking about?
blue line,
Yeah.
and then here through the orange line.
Does it make
So this is actually an unbounded.
So is there a solution?
Yes, there is. But in this case, we won't have both a max and a min. We're only going to have one.
So there's only 2 points.
So we only have 2 points we need to evaluate. We have this one right here, which the coordinates are
-6, 0.
0, -6. And then we have the next point, which is this one, which is right here. And this one is at
-4, 0.
-4, 0. So what I'm going to do is evaluate each of those and plug those in, and then we'll talk about why we only have one solution. Okay, so if I plug 0, 6 in, I get 9 times 0 minus 6 times -6.
36.
So I get 36. If I look at the next one, I get what? -36. Now remember, an unbounded only has one, a max or a min. So I need to look at some of these other values. Is there a way that I could get a number bigger than 36 or a number smaller than -36?
You could make it 1 and negative 1.
What? So, well, let's think about something.
What if you brought the whole thing down by
Now what if you use it? You use a top point up there?
What?
You use a top point up there?
You have to use this equation.
I know the point. Top one.
So, like what top? You can't use that because
Those were on forever.
let's just try. Would you agree that the point -3, 2 is in the graph?
Yeah.
It's part of the graph? Let's just plug -3, 2 in and see what we get.
So any point in the graph.
Any point in the graph. Let's just try. Remember, our goal is to prove that one of those is not like the min or the max. So if I plug in -3, 2, what do I get? Negative
39.
39. So is -6 really the lowest number? No, it's not, because you have now -39. So really, what I'm going to do is I'm only going to have a maximum value. Now the question is, how do you know which one to focus on? And the answer is it's just trial and error. Okay, with an unbounded, you will only have one max or one min. You will not have both. So then our goal is going to be to try and disprove. Why did I choose -3, 2? Because I looked at this thing right here, and I know if I plug a negative in here and add it to another negative, that's going to give me a negative answer. Okay. So that was why I chose to plug those in. Okay, now let's go ahead and let's skip to the optimize real quick. Okay, we're just going to briefly go through this. I don't know if you necessarily need to write this down. Okay, but optimize means to seek the best price or amount to minimize costs and or maximize profits. So that's pretty much what we've already been kind of doing in a way. Okay, optimizing is seeking the best price or amount to minimize costs or maximize profits. And so what we're going to do is, in our last example, we're going to go ahead and look at an optimization problem. Okay. For sake of time, I'm going to go ahead and move on. If you didn't quite get it written down, I'll go back at the end, and then you guys can go ahead and write it down when I'm done there. So let's go ahead and look at this example. It says, each week Mary can make 10 to 25 necklaces and 15 to 40 pairs of earrings. If she earns profits of $3 on each pair of earrings and $5 on each necklace, and she plans to sell at least 30 pieces of jewelry, how can she maximize profits? So we have to write the equations. So let's first of all start with the necklaces. I'm going to let that equal x. Okay? So we know that x has to be between what two values? 10 and 25. So this is going to look real similar to something we've already done. Okay? What do you think you're going to let earrings be?
Why?
Why? So, what can you tell me about y?
Y is
Yep.
greater than 15 and
Yep.
equals
Less than 40. So basically, in other words, y is just between 15 and 40, right? Y is just between those two values. And the last thing they tell me about the jewelry is that she plans to sell at least how many pairs? 30. So I know that x is my necklaces, y is my earrings. So I know that
X plus
Y is greater than 30.
30, good. Greater than or equal to 30, nice job. So those are your three equations. Now what we need to do is come up with our maximizer, or our profit. So our profit equation is going to use the numbers, actually the dollars. I said that wrong, not numbers, the dollars. So in this case, the profit is going to be 3x, yes, good job. And then, plus what? 5y. So now if you notice here on your graph, I obviously didn't give you 25 spots and 40 spots. So what do you think you should go by? 5s. Let's make things easy. Okay, so we're actually going to go by 5s here, folks. So all we're going to do now is we're going to go ahead and go x is between 10 and 25. So let's start, 10 and 25. I'm going to have a vertical line at 10 and a vertical line at 25. What's wrong?
Isn't 125 necklaces are X, which would be 5X and 3Y.
Oh, okay, it should be 5x and 3. Okay, yeah, we can change it, sorry. It's okay, we can take care of that when we evaluate. There. Okay, so let's go ahead and fill in those. On the next one, you get y is between what two values?
15 and 40.
Yep, so you're going to go 15 and then 40. 20, 25, 30, 35, 40. Oops. So I actually didn't go up my yellow enough. Oops, went too far. There we go. Okay, so x plus y greater than or equal to 30. What's your y-intercept going to be? 30, good. 15, 20, 25, 30. And then what kind of slope?
-1.
-1. So this is the thing. With the -1 slope, even since we went by 5s, since each of them are by 5s, if I go down 5 and over 5, that's a -1. Okay. Which way are you going to shade? To the right. Good job. So let's see what we got. We have a boundary here. 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 Ooh, got lots.
I'm gonna shade.
So there you go. That's the boundary. So you have 5 vertices. So then now let's go ahead and put our points in. Okay, what's our first point going to be?
5, 10, 40,
10, 20. 10, 20 is 1, and then you already said 10, 40. Yep. $15, $15, good. 25, 40, and 25, 15. Now, real quick, if you didn't change that, okay, it says that she earns a profit of $3 on each pair of earrings, so that's why it's 3Y. $5 on each necklace is 5X. Okay, so I need to plug each of those in. So first of all, let's start real quick. If I plug 10 in for X and 20 in for Y, what do you get?
130. No, 80. No, 110.
110. So now let's plug in 10 and 40. So you have 10 here and 40 here. What do you got now?
120 is 170.
170. Okay, 15, 15.
45,
85, 120.
And 120. What about 25, 40?
245.
You got 245?
275.
It should be 125 and 120. 245.
45.
What about the next one? 25 and 15. So where are they going to make the most?
245,
25
25, 40.
Yep. So 25 necklaces and 40 earrings. Okay. Okay, your assignment then.
There's way too much.
Page 157, you have 8 through 16, the evens.
Oh, man.
Okay. Now, 8 through 12, and then 14 and 16. Yep. Actually, I will cut that back. 8 through 14, the evens. Okay? So 8 through 14, the evens.
I'm happy with the case.